Okay, so good afternoon, everybody. Welcome to this Telecoms Academy Insight webinar. Today's topic, 5G technologies and business, and really just a look at where we think the direction of the communications industry is going. Now, just a few sort of introductions first of all. We are, of course, the Telecoms Academy. You'll probably have a pretty good idea of who we are. In terms of what we can do, we've got what we refer to as the School of Telecoms Management, in which we do a lot of executive style courses. So things like Telecom Mini MBA. We've got leadership, marketing, finance, and so on as part of that package. Something I'm probably more involved with than anything else here at Telecoms Academy is the advanced communication technologies. So anything from LTE, 3G, 5G, of course, planning programs. So some fairly detailed technical topics that we can cover as well in classroom type formats, 2 days, 5 days. But of course, pretty much everything we do as well is available through a correspondence program or our distance learning programs. The interesting thing about the distance learning programs, and one or two of the executive courses we do, is that we have an arrangement with Derby University. So if you complete a certain amount of work that we set, we can push it out to Derby University here in the UK. They can accredit the work and issue with a qualification, with a university accredited qualification. So if you have any interest in the other things that we do, in particular that Derby University accreditation, then head on over to our website, and there's plenty of details on there related to those. I should also mention that we have we're owned. We're the Informa Telecoms Academy, of course, is a very big organisation, but part of the organisation is Ovum, so Ovum Research. So a lot of the information that we use, particularly in the executive courses, are based on the forecast and the data that we can pull directly from the analysts that work with us, which we find extremely useful as we're presenting a lot of the, particularly strategy courses. Our analysts, of course, are spending quite a bit of time thinking about the direction the industry is headed, and we've got direct access to that information that we can inject into our training programs. Right, so on to today's topic. Which of course is 5G. So what we're going to cover more or less, we'll talk a little bit about the capabilities and what we expect it to do. We'll address very briefly the core network technologies and the access technologies, and then we'll finalize it with a very brief chat about spectrum for 5G. Now we're only going to be online for about 30 minutes or so, with a few questions at the end. So any questions that you've got, if you can save them till the end, that'll be fantastic. And I'll do my best to answer the questions that you've got. Again, we'll probably have to call time on that at some convenient moment. Right, I suppose 5G would warrant some form of definition here. I suppose maybe the best definition of it is in terms of the standards bodies that are building the technology, or at least building the ideas that will become the technology. Of course, I'm sure you are aware that there's an organisation out there called the ITU, and one of the projects that they're currently running is a thing called IMT 2020, and that number there is quite a big clue, really. That, of course, is the date. So 2020 is sort of the expected date when the standards, the technical documents that describe how this thing is going to work, when they should be complete. And shortly after that, we'll start to see commercial networks rolling out their 5G technologies. But 5G is not just one thing. It's not just one new technology. It's really just a collection of technologies that is growing out of the current technologies that we have. So the likes of LTE, LTE Advanced, and evolved LTE as well. Of course, one of the big things, because of all of the new applications that will likely be running over the top of 5G services, that we need more capacity, more efficiency, lower latency, those kind of things, and to solve some of those problems, it's pretty clear that what we need to define, in some sense, is some new parts to the radio access network. Obviously, in these mobile radio networks, the capacity bottleneck has always been in the radio access network, or on the radio interface particularly. So if we're going to be talking about gigabits per second, tens of gigabits per second, obviously we're going to need some new radio technology. So that's going to be part of the specifications as well. And what we kind of hope as well is that the way that we build the radio access and the way that we build or think about the core network, that should lead to some levels of increased efficiency as well. Yeah, certainly increased efficiency in terms of the bits per second per hertz and some technical stuff like that, but really in terms of energy consumption, mobile operators have got a pretty big electric bill to pay at the end of every month, every year. but it's efficiency of service as well. So I put on here things like provisioning. So just how easy is it to create a new service and inject that service into the network? How long does it take? How easy is it for our customers and partners to be involved in that process and so on? So we're hoping that kind of network flexibility, using things like NFV and SDN, those technologies, just how easy is it to form partnerships with our business partners particularly. So making use of some of these newer core network technologies, then this idea of sort of modular systems, self-configuring systems, and that's one of the other ideas that leads to efficiencies within the system itself, particularly around the idea of energy efficiency and provisioning efficiency. But one of the big things that we probably need to address at some point is, what are we going to use it for? Now, as we saw from some of the comments on the first page there, things like IoT, smart networks, sensor arrays, that seems to be, at the moment at least, the biggest driver for 5G networks. Now, I'm sure you're all aware of various predictions that have been made about the number of things that will be connected over the next sort of couple of decades or so. And I think Cisco and Ericsson have made predictions saying that by 2030, I think it is, there'll be something like 50 billion things connected to the internet. Not all of those via a system like LTE, but there'll be low power, short range communications as well as the wide area cellular communications. 10 billion of those things, by the way, will still be smartphones and tablets and things that we would recognize as phones, I suppose. But that kind of leaves 40 billion other things that need to be connected to the internet. So clearly, if let's just say 30% of those things have to be connected via something that looks like a cellular network, well then 10 or 20 billion things connected to a mobile network. Well, we clearly got to think about the way in which we not just design capacity into the network, but imagine the provisioning process. If you're going to have, well, there'll be some big networks today that probably have 20, 30 million subscribers, and that would be classed as a big network. But in the future, by the time we get beyond 2020, and we're going to connect all of these sensors and smart cars to the network, you'll be a big network then when you've got 500 million or 700 million connected things to the network. And think about that provisioning process. I mean, how do you even create those subscriptions? How do you bill for them? So a lot of that definition of the services and the business models has to lead into the design of the network as well, and how easy can we make it to perform that type of relationship building, partnership building with our businesses. So there's quite a bit of work to do, and it's as I say, it's not just one thing. It's everything from the mobile equipment or the user terminals all the way through to the back end provisioning systems and the interfaces that we would have out to our business partners. All of that really has to be part of a definition of a 5G business. Maybe the best document to look at the moment, if it's your first time thinking about 5G, then you need to kind of hit Google and look for this NGMN white paper. So this is the Next Generation Mobile Network Forum. These are the addressing the words of the ITU in terms of their IMT 2020 project. This is a really good starter document to try and find out what it is, what is meant by 5G. So one of the interesting things that we find in this document are these so-called use cases. Now, what they're not trying to invent or think about every single possible use case that we might have in the future, but as it says in the second bullet point there, rather just as a tool to ensure that we understand what the capabilities of the network should be if these are the things that we want to use the services for. And there's a pretty wide range of different kinds of service in there. I mean, here's your sort of massive Internet of Things. Okay, those sensor networks, and for the most part, the sensors that exist in the Internet of Things, they're not. The applications running on these devices don't really have a massive broadband requirement. I mean, your refrigerator, your car, your sensor array, I mean, these things will presumably not be streaming movies, playing online games, that kind of thing. So it's mostly telemetry, it's small packets of data, but of course it's billions of small packets of data, and that's one of the reasons that we might need a very high capacity network. Maybe more obvious things would be things like broadband access in dense areas, example there of pervasive video, and broadband access everywhere. I mean, clearly these will be addressing user terminals, so your smartphones and tablets and such like. But one of the interesting things that they can do, or what they have done by defining these use cases, is to try and estimate what we think the capabilities, in terms of performance, the latency, the throughput. What should the performance be of a dense area broadband access? So This is just another snapshot of from that same document, from this NGMN white paper. Now, the interesting thing about this table here is often when we quote the capacity of a system, we're talking about the capacity of the radio cell, and then of course that has to be shared between, you know, however many things might be connected in that radio cell. But in this case, these are user data rates, which is pretty astonishing, really. So, for example, we'll look at the most challenging one here. This indoor ultra high broadband access. So in the downlink direction, a gigabit per second. In the uplink direction, 500 megabits per second with, you know, 10 millisecond latency, albeit rather low mobility. But if you're indoors, you're probably not moving that fast anyway. But those numbers that you see there, 1 gig and 500 meg, this is the expected experience of an individual terminal, so an individual user effectively, that finds himself in that environment. Now, I'm not showing it here, but in the document it goes into a bit more detail and talks about a sort of a high-density office environment, for example, where there may be multiple terminals running demanding applications. So in a single office suite with maybe 20, 25, maybe 50 computer terminal type devices, then what it's suggesting here that every single one of those terminals within that room could experience a 1 gigabit per second downlink capacity, which is pretty astonishing, really, and clearly I mean, the current generations of technology that we have, even, you know, the most advanced of LTE advanced systems, you know, are unable really to provide that kind of capacity. So clearly we're going to need more spectrum, we need fancier antennas, we need a different type of radio access really to be able to provide those types of services. But I think well, a challenging one for the operator maybe would be this sort of 50 megabit per second everywhere. There's, you know, broadband everywhere, where we're really looking at sort of, you know, 50 megabit per second for everybody, including rural areas and so on. Or maybe when we get into the very rural and open areas, perhaps, you know, 10 megabits per second per user is a bit more of a reasonable expectation. But you can see by defining these different use cases and maybe even categorizing certain applications that might be used in those cases, you can start to think about what the end-to-end process of building a, you know, next generation network should be. You know, including things like the provisioning system that will have to sit at the back end of the network. So I'm not going to go through everything in the table, but what I do recommend you do is you hit up your Google search page and look for the NGMN 5G white paper document, version 1 I think we're still at. It makes a really interesting read. Not a technical document really, but it lays out some of the requirements and some of the challenges that should be required for developing 5G as a you know, a specified or as a standard technology. So we should probably say something about the what the core network might look like, and of course this doesn't really look like a core network, but I think what I'm trying to demonstrate here is that we've seen this probably even over the last 15 years or so, in that we like to separate the network into these various layers. In that you've got your transmission layer, this sort of bit that would sit right at the bottom, I suppose. So this is your, these are your bit pipes and maybe the basic switches and routers that we have in the system. But really what we want to do is we want to remove from this transmission infrastructure any sort of direct connection or dependency on the service, because, you know, honestly, at the bottom of right at the bottom of the network, your fiber optic cable, your Ethernet cable, your radio base station, you know, these things really don't care what the service is, so their job really should just be as efficient and as high capacity as possible. One of the challenges, though, is, I mean, I've got the big words there, the hyper-connected infrastructure, making sure that everything is connected. And it's not just about, you know, a new radio access technology, which inevitably we will see, but it's the interworking and the interoperability between many different kinds of radio access technologies. And that leads more to sort of a heterogeneous network type environment, which again is, it's old news, really. You know, we've kind of been thinking about maybe building those networks to some degree already, but really what we want is a kind of just a dumb transmission network that will do as it's told, and doing as it's told means that we have to have a sort of a layer above the transmission network, which will define what services and what configurations we really need within that network. Now, this sort of enabling layer that we have here doesn't really act on its own. There will clearly be some basic functions in there, such as, you know, we need to define what the basic, you know, telecommunication functions would be. But it's the layer above which I think is the interesting one. I mean, this is sort of I guess, an application layer, I suppose, if you wanted to call it that. But this is this is how we expose the capabilities of the network to the industries that are interested. It could just be, something as simple as providing a best effort internet connection. Undoubtedly, we'll still have those things in, 5 or 10 years' time. But it's the other industries. I mean, the IoT industry, the sort of, the massive interconnectivity that require, and I've just got a couple of there. So basic machine to machine, healthcare, automotive, industrial applications, smart buildings, smart cities, all of those kind of things. Well, each individual application that you care to define within those categories will have some very specific delivery requirements, in terms of the speed and latency and so on. So really what we need to do up here is to sort of build the application, get the application to understand what its requirements are, and communicate these into this enabling layer. And that enabling layer in turn will provide the configuration processes, which it will then communicate to the transmission network underneath. So we've got these various layers that can work in conjunction with each other to ensure that whatever the application is, they experience the required throughput, latency, quality, reliability, and so on. Now, one of the big questions maybe in here would be, who's going to do what? Because we're very used to this idea that the operator is they're the people that might be design the network. They work with their vendors in order to build and create the network. But who should it be that defines and builds all of these applications up here? I mean, clearly there's never going to be a one size fits all or killer application for this. And it seems unreasonable to expect the operator themselves to think of and develop all of the applications for these, new business segments that might occur. So in a way, what we've got to do is to simply provide an environment where we can let somebody else build the application, but a standard means to communicate into the network. And again, this is not a new idea. And I'm sure some of you out there have heard of this idea of APIs, these application programming interfaces, which form an interface between, maybe this external organization and the communication network itself. But I think that's one of the key areas. That's when we think of the business enablers or developing new business cases for 5G. I think that boundary between the sort of the enabling platform and the application environment, I think defining what that is and how we can expose the capabilities of the network in a simple way, sort of simple in air quotes here. It's never going to be that straightforward. And that means that you can let the automobile industry develop their own applications, understanding what the capabilities of the network might be, without needing to understand, how to build a communication network. In the same way that if I'm an operator and I'm building a network, I don't need to understand how the vehicles need to operate. I just need to understand what their basic communication capabilities are. And we can swap and exchange information at this level, which is advantageous to both parties. Now, we've got a slightly more complicated picture here. This is there's a group of people out there, there's a forum out there called 5G PPP, and again, I recommend that you track those down on the internet. They've got quite a few good white papers on some of the challenges ahead. And this is a slightly more complicated looking picture, but again, we've got those same sort of network boundaries. Maybe we'll call them slightly different names here. So you've got the business services layer. So if I'm VW Audi or or Alfa Romeo or somebody, well, I'm sitting up here and I'm developing my self-driving cars and my fleet management tracking and so on. So I'm developing these applications, and now what I need to do is to communicate with an operator or some intermediary. Maybe it doesn't necessarily have to be the operator, but I need to communicate that into this sort of business function layer. Now, you'll notice these sort of funny little blue and purple things here that look like documents. I mean, I suppose what we could really think of these are as a configuration library. Okay, so this application needs, and then we describe what the requirements are. And again, it's the usual things. What should the throughput be? How long can I wait for the connection? How big will the packets be? What state of mobility is required for those services? And once we've defined this this library of requirements, then we need to be able to communicate it really down into the infrastructure. Now, it's difficult to kind of really imagine the scale of these things, but if I've got a network with 1 billion things connected to it, and I've got 50 different industry partners, clearly the network is going to require a great deal of management, and that's really where the importance of things like orchestrator functions come in, because there are many parts to the network, including the infrastructure layer, the network function layer, and so on. And what the orchestrator really has to do is to understand what the delivery requirements are for a service and make sure that all of the correct elements of the network are configured in the right way. Now, again, not necessarily a new idea, and certainly when we start thinking of the current evolutions of the network, such as SDN and NFV. These ideas are already, kind of current, I suppose. And okay, so if you're not aware, I mean, software-defined networks. I've got a couple of bullet points there that more or less describe what this thing does. So it's a method of centralized control for transport networks. So rather than giving an autonomy to a switch or a router in a network, where it will decide the direction it sends a particular packet, there can be some degree of centralization control. And if you centralize the control, that centralized process has got a much better view of how the network resources are being used. So we can make sure the packets always go in the correct direction for the quality of service required. It means that we can have more complex rules for data flow. So when you've got 1,000 different applications running through the network, not every single packet related to those applications should necessarily always go down the fastest route. So you can use or preserve the resources just for those applications that absolutely have to have low latency or high peak throughputs, and so on. So these rules for the data flow mean that we can probably better manage the quality of the service and such like. Now this little diagram sort of in the top left here, I think I pulled this from an Etsy document, but you'll see it's very similar to the 5G architecture that we've got, in that you've got your business type applications and some form of interface that allows us to communicate with a controlling layer. So these are these so-called network services here. Really, these are the things that understand what it means to be a switch or a router or a database and so on. And then you've got your basic network devices right at the bottom here. So these are the parts of the networks which will, for example, forward a packet of data, or you're managing a queuing process in some part of the network. The other part too, this kind of harks back to the idea of network flexibility, but certainly network function virtualization, or NFV. Again, not a new idea necessarily. I mean, both of these ideas have been around for what, 5 or 6 years or so now, and mobile operators are beginning to implement these things even in today's network. But they play a big part of our future generation, so 5G networks. And the idea of network function virtualization is, well, basically, the network functions can be executed as a software rather than in any dedicated pieces of hardware. So, I mean, well, if you just take the word network function, for example, when you can say switch and billing data, billing center, firewall, router, all of these things are network functions, and they don't need to be in any dedicated pieces of hardware. And in fact, what this function allows us to do is to use, well, if you look right at the bottom of this picture, by the way, is an Etsy reference diagram. So things like software-defined networks and network function virtualization are emerging as standards within the industry, which should simplify things maybe a bit going forward. But when you look right at the bottom of this layer where it says the hardware resources, these are what are sometimes referred to as COTS, okay, common off-the-shelf, computing platforms. Okay, so your telephone switch or your big network router now doesn't really need to sit on anything which is an expensive and dedicated function hardware. You can just buy any old, well, perhaps not any old, but you can certainly buy more generalized computing hardware. And then this virtualization layer that sits in the way here can actually dynamically use the resources as and when they are required. So if one of these network functions here happens to be at that time of day a function that requires a lot of processing capability, well, then this virtualization process here can basically assign more computing resources to that function. And when you no longer require those resources, we can assign it to a different network function. So it can lead to much more efficient network infrastructures. And try and keep in mind as well that when we talked about these these configuration libraries, then really what those configuration libraries, one of the things they'll have to say is how much computing, storage, or memory resources will be required in the network, and that allows then the orchestration functions to ensure that we've got the right resources loaded into the right parts of the network to support that particular application. So things like network function virtualization and SDN are a really important part of 5G networks going forward. I've got a slightly sort of this sort of final bullet point down here. I've got a slightly contradictory bullet there. Enables centralized or decentralized network function. Well, if my network function can be defined by software, I could, if I want to, I could centralize the whole thing. I could even make use of a cloud service and put my entire network and all of the network functions up in somebody else's cloud, and I can just lease it from them in a way which suits my business case. But really what we're saying by that is we're saying it doesn't really matter then necessarily where the network function lives, and I can put it up in somebody's cloud. I can distribute it within my own network if I want to. I can build my own data center, but maybe make use of some third-party data center at the same time. So it's flexible resource usage really, and part of that is I mean, this is another part of another ETSI standard. In fact, this mobile edge computing. Again, an idea that's been around for a while. Saying, well, actually, there are some applications, perhaps those that require really low latency, for example. We don't really want the data center, we don't want the network functions to be in some distant cloud in some third-party network on the other side of the Pacific. We might actually want a lot of the computing power and process associated with those applications to be as close to the device as possible. So mobile edge computing actually allows you to distribute the specific functions really into the radio access network. It could be something as simple as caching content. You know, the latest viral video, for example, could be cached towards the edge of the radio access network, and when somebody makes a request for that application or for that type of content, then it can be pushed directly from the radio access network, as opposed to have to pull it from the back end of the network, which of course, you know, may lead to, well, certainly lead to latencies, but there might be a cost associated with that as well, because you've got long distance transmission to think of. So another important part of 5G will likely be mobile edge computing. Now you're probably getting the idea here that you know, as I said before, 5G is not just one thing, but is likely to be a collection of things. So far we've got mobile edge computing, NFV and SDN as maybe emerging standards from ETSI. They'll be adopted by, well, a body like 3GPP, and will be turned into some proper technical standards. So if I need to build a network, I know which documents to go to, what protocols to use, and so on. But there's a lot of work yet to do with that, and as I said, we probably won't see any proper specifications until getting close to 2020. Now, one of the other questions I asked you at the beginning of this as well, you know, what do you think the important technologies are? Well, you know, clearly a new radio access technology is going to be required at some point. Two schools of thought here, really. You can see on the left-hand side here, we've got technology candidates for evolving LTE, which makes this an ELTE, which is rather confusing, evolving long-term evolution, but don't think about that too hard. But you've got a number of different options in here. You know, one thing that we might need, I mean, there's just, again, I'm not necessarily going to go through all of these, but for IoT and machine-to-machine, well, if you look at current LTE with its 20 megahertz channel or its 10 megahertz channel, not all of those applications, as I say, really need broadband connections. So there's a little bit of scope for developing within the LTE specifications, maybe a low power or narrowband LTE, which might serve the needs of a smart city, you know, for short range, low power communications. So that means that this evolving LTE means that we can extend the life of the current generation of technologies, and we can keep it as close as possible to being maybe backward compatible. So we don't need to make any major changes to the current base stations, to the current architecture of the radio access networks, and so on. Inevitably, though, we're going to need, you know, new radio channels. We're going to need, you know, 200, 500, you know, megahertz radio channels, and we've got to find spectrum for that. And to make use of that spectrum as efficiently as possible, there's a series of, you know, investigations going on at the moment about, you know, generating new waveforms which are more efficient. As you can see here, it says, you know, localization of interference, so we're not leaking into other bands and so on. And to support things like low latency communications, and I probably didn't point it out on one of those tables previously, but there is one of those use cases that defines the need for a millisecond latency. And given the current LTE frame structure, the TDMA frame structure of LTE, that's not actually possible. I think the minimum time delay that we can really get down to is about sort of 5 to 10 milliseconds. So the actual frame structure and you know, the symbols and the modulation, everything else really needs to be changed quite a lot in order to achieve those very, very short latencies. So we'll undoubtedly see a new radio access technology. In fact, what I suspect is we're going to see several different new radio access technologies, and that might be on a sort of per application basis. Where the application might be a smart meter, or a self-driving car, or an intelligent transportation system that needs to run at high speed, for example. High-speed trains, that kind of thing. Because when you look at all of these different applications and perhaps their conflicting requirements, it's very difficult to build a radio interface that suits everything. But we're getting pretty good at building radios these days. I mean, thanks to the likes of Qualcomm, Broadcom, the chipset vendors, and also a technology that's been around quite a long time. But I'm sure some of you are aware of this. But SDR, or software-defined radio, so we can build maybe a common chipset that can load up whatever radio protocol we need. So it's not the end of the world now if what we end up with will be multiple radio access technologies, because going forward the chipsets will likely be able to support all of the required waveforms and power outputs and modulation coding schemes that we really need. So it's not going to be easy. It's going to be complicated, I think, because there are going to be a lot of new things out there. But one of the key issues at the moment, I think, is when you look at the timeline of all of this. I mean, clearly we're sort of sitting around about, we're somewhere in the timeline around about here at the moment. So we've already got well underway, a lot of LTE advanced networks being released. I think if you look in Turkey, for example, I think Turkcell and at least one other there, they definitely have a 4.5G network, and maybe even we could call it LTE Advanced Pro. But certainly what they're declaring is very, very high throughputs, in excess of a gigabit per second. But we've got release 13 and 14 to come yet, and there's a lot of new things in there, higher order modulation coding schemes, more complicated antenna systems and so on. So what we're doing really is we're evolving the LTE. Okay, so until we have a 5G or a technology that we can call a 5G, we have to continue to evolve the existing technology, which sort of renders a bit of a problem in that when the 5G thing comes around, is it going to be backwardly compatible? Is the evolving LTE going to be forwards compatible? Just how different is it going to be, both from a radio access perspective, but also from a core network perspective as well? So there are some questions that need to be answered here about, what should the type of integration be between our 5G and legacy systems? Should it be a loose integration with simple interworking interfaces, or does it need to be more tightly integrated, even all the way down to a radio interface perspective? So I've stolen a picture here from the NGMN white paper, which I think describes a number of these options. Option 3 potentially being the favourite. It's also the most complicated as it happens. But if we just take option 1 for a moment, again, we're not going to spend too much time on this, so you may need to find the document and read the words associated with this. But on the positive side here, it really means if we go for this first option, what you'll see in the grey bubble here, this new rat, it says, well, that's basically the 5G. Okay, there's your 5G, new base stations, new radio interface. But the key thing here is that the existing core network function, so my LTE EPC, will in fact manage that radio access network. Okay, so this interface is perhaps a new interface, so maybe there's a little bit of complication there. But it means that we're not building a complicated new, 5G core network. The existing functions can probably do it, although by using existing functions within the network, we may be sort of holding it back a little bit. All of these fancy new applications that we want to use, maybe we need to define new core network architectures to handle that. So option 2, slightly more complicated in that, okay, now we've got a new radio access network, and now we've got a new 5G core network in there. So that 5G core network, of course, can be optimized to work with the 5G radio access network. That's a nice thing. But when you start thinking about interworking, you've probably got to have some kind of interface that would allow the 5G and the legacy systems to interwork, maybe even at just at a core network level. So when we're going to do things like handover, for example, between the 5G and the 4G, that's generally speaking what we'd use that interface for. But when you get into the sort of the advanced ideas of maybe using both the 4G and the 5G collaboratively in something like a coordinated multi-point transmission, with carrier aggregation and such, well, then we need some. This is when we start talking about tight integration between the two networks. Option 3. Well, this might even be a timeline, I suppose, you know, because we could sort of evolve out in this direction. In that by the time we get to option 3, we've probably got, you know, the most complicated kind of network. In that I have a 5G core network, which of course controls its own 5G radio access network, but we've also got 5G core network here that can control or talk to the legacy system. Now that might be a good idea because it's easier probably to make it backwardly compatible because we've already built the thing that we want to be compatible with. But again, you've got to now inject all of those 4G style functions into the 5G network, and I guess we could talk about whether or not that again holds back the 5G capability. Shouldn't do really, because you know, when you address things like network function virtualization in there, you could have some 4G parts sitting on your processor and some 5G, you know, functions sitting on that process. So maybe it's not going to be too difficult to do that. Wi-Fi's in there as well. I've not really mentioned that, but you know, Wi-Fi is probably going to play a fairly key part in the delivery of services. Maybe not this generation of Wi-Fi, but whatever it's going to look like in 5 years' time or so. So you know, there's quite a bit to think about there, and I think I mean the guys obviously 3GPP are down there, you know, in the South of France and various other places, you know, currently evolving the LTE standard that we understand at the moment. Obviously, what they've got an eye on is what's going to happen with 5G. So they really need to think about this this interworking, this interoperability, and trying to, well, from an operator's perspective as well, you've got to think about the cost and complication of rolling out yet another new technology. But just I mean, if you are an operator, or if you're consulting with an operator, I still think that the thing that needs to be defined right now, and I think if you're an operator, you need to be quite clear about this, about what your next generation business is going to be. We understand, I think we understand quite well, that the normal subscriber, so you and me with our smartphones and our subscriptions, you know, well, two things happen really from a human perspective, is that we want it to get faster. And we don't want to pay as much money. Okay, so that business is almost like a dead-end business, really, unless we can come up with some clever new things to, you know, make you and me part with more money. It may not be sustainable in the long run. We've got to think maybe 10 years, 15 years into the future here. So if you're an operator, you've got to say, well, okay, where's the next generation money going to come from? And it has to be, I think, from what our analysts refer to as the industry verticals. So this takes us right back to the beginning again, where we talk about, you know, it's the smart cities, it's the automobile, it's the healthcare, and so on. So, you know, a lot of thought needs to go into what is it that these industries want to do, and what network functions do I need to make available in the network? And I don't think there's anything, I know we're not anywhere close to 5G yet, you know, it's still, you know, 3.5, maybe 4 years away for most of us, or longer. But I don't think there's anything wrong with thinking about those business cases right now, because for you know, 4G LTE and certainly LTE Advanced can do a lot of the things that we might want 5G to do anyway. Maybe not as efficiently, and maybe not to the same kind of scale, but you know, if we're developing those business cases now and over the next 5 years, and when 5G finally comes along, you know, and your favorite network equipment vendor can now offer you 5G network capability, well, you've already developed that business, and you can maybe make it more efficient and, you know, better, faster, more efficient for those business partners. So there's quite a bit to think about, but yeah, clear definition of the business case, I think, is absolutely key to understanding what 5G is. So just a couple of notes on the spectrum. I'm not going to spend too long on this. We're pretty much out of time now. But obviously, when we start looking at gigabit per second data rates, or multiples of tens of gigabits per second, then we need more spectrum. That's basically what it comes down to. Some estimates, again, from this ITU report, reckon that we need, well, pretty much close to about 2 gigahertz of spectrum will be required. It depends where in the world you are, and that's more or less what this table down here says. But you know, the most sort of, you know, pessimistic estimates say that we need another 2 gigahertz of spectrum to fulfill all of the requirements of 5G. A little bit of work was done at the back end of last year. I mean, there was a WRC 15, sort of, I think, November, December last year, World Radio Congress. Yeah, a bunch of people get together in a room and talk about spectrum. And one of the items on the agenda was trying to find spectrum that would be potentially useful for, well, IMT technologies, not necessarily 5G, but things that could be used for 5G in the future. And the bands of interest, and I think there were some resolutions made on this, was around about the 1400, 1500 band, and the around about the 3600 band. So there's quite a bit of spectrum in the 3600 band. You can see there's what 600 megahertz of spectrum there, which is potentially useful. It's kind of high up in the spectrum though, and those of you that in the radio planning departments will probably be getting a little bit nervous about that, because it's very difficult to build a reliable network from those high frequencies. But that probably suits the more your low power, low range applications, whereas the lower frequencies that we might have to talk about will be more suitable to the wide area cellular type communications. And then just something to keep an eye on, I think WRC 18, so a couple of years away yet, but they need to find more spectrum still. And that's going to come from much, much higher up in the radio spectrum. So these numbers along the bottom, by the way, are gigahertz. Okay, so we're talking about the use of the 60 gigahertz spectrum, 70 gigahertz spectrum. There's a lot of spectrum up there which is potentially usable. Again, maybe on a very short range basis, but if we're talking about indoor environments, indoor high capacity applications, that spectrum's probably okay. And it lends itself quite nicely as well to the formation of advanced antenna techniques. So you may have noticed on one of the diagrams that I didn't really spend much time on, but a thing called massive MIMO. And massive MIMO, well, the antennas may well themselves be physically massive unless we're using very short wavelengths, and that's what you can get from here. So you can build a relatively compact antenna with very high degree of capability out of the higher spectrum services, or high spectrum frequencies. So yeah, spectrum is just another area that needs to be thought about in that respect. Now we're pretty much out of time. Of course, I'd love to keep speaking about this all day, but I have to stop. Anyway, there's a reminder of what we do, and there is some contact details at the bottom. So telecomsacademy.com. So yeah, head on over to that website, figure out what we can do for you, and you might be interested, since you're sitting on this 5G webinar. But we're actually running a 2-day course on 5G technologies and business, and that's going to be in London, 15th, 16th of December. So again, if you're interested in that, yeah, go on the website, or use the phone number you can see at the bottom, use the email address, speak to our sales team about availability on that course.